Okay, so on to the second part of this annuity example. So again, it's how much will the annuity cost, but we're factoring in that we might want that 15,000 to increase over the course of our retirement. So how much would the annuity cost if you want the payment to increase by 4% annually? Okay, so we'll set it up the exact same way. So how much will this annuity cost? So the first payment is 15,000 received straight away at the very start. Okay, that's fine. That doesn't need to be increased, doesn't need to be discounted because it's been received at the very start. Again, we're taking the 68th birthday to be today. That's the point of view we're looking out. The point of view we're looking from. So it's to there that we will discount our future flows. So it's 15,000. In a year's time, then I'm going to get another 15,000, but increased by 4%. So in a year's time, I'm going to receive 15,600 euro, and so on and so on. That's going to increase by 4% every year. Now, this amount, I'm receiving it in a year's time. The annual interest rate, they haven't said changes in the second part, so it's still 3%. So discount that by 3%. Plus the following year then. So you've got that 15,000 I started with, increased by 4% and increased by 4% again. So I'm going to multiply that by 1.04 to the power of 2. And then it's discounted twice as well. All the way until at the start of the 20th year, you're going to receive a 15,000. Increased by 4%. How many times? So again, like at the bottom here in the first part, it's increased 19 times because you're receiving it at the start of the 20th year. If you were receiving it at the end of the 20th year, if you're receiving these flows at the end of the year from the start, this would have been discounted and this would be discounted 20 times. Because it's at the start of the year, I only need to increase it 19 times, and then on the bottom, I only need to discount it 19 times. So again, I've got a geometric series. Again, my first term is nice and straightforward. It's 15,000. What is my OR here? What am I increasing by each time? Well, on the top, I'm multiplying by 1.04 each time. And on the bottom, by 1.03. So that's your OR, 1.04 over 1.03. So if we just write our formula again, so Sn is equal to A on 1 minus OR to the N over 1 minus OR. So that's equal to 15,000 on 1 minus, it's 1.04 over 1.03. So again, the N is 20 here. Because even though I only discount the last one 19 times, there is this one at the start which isn't being discounted or increased at all. So there is 20 here. All over 1 minus 1.04 over 1.03. So plug that into the calculator. So 15,000 multiplied by 1 minus 1.04 over 1.03 the 20 is equal to that divided by 1 minus 1.04 over 1.03. 329,350.37. Okay, so it costs nearly 330,000 euro to buy this annuity. It's more than the first part, which was about €100,000 more than the first part. But again, that makes sense because it's increasing by 4%, so it is going to cost more to purchase, and it's increasing by 4% each year. So, like, even if what would the last payment be? 15,000 multiplied by 1.04. So 15,000 multiplied by 1.04 to the 19. So like that final payment is over €31,000. It's doubled compared to the first one because you've increased it by 4% so many times. So yeah, it makes sense that it would be a good bit higher in the part 2 to purchase. So I would say part 1 and 2 there are the most common way this will be asked, the most common thing you'll be asked to do. 3 here I just want to cover off, less likely I would say to come up, but what if you wanted to receive the €15,000 from part 1 indefinitely? So how much would this perpetuity cost? Okay, so we're not saying at the start that we only want to receive 20 15,000s. We're saying we want to receive 15,000 indefinitely. This is a pension product, so 15,000 until we pass away. Okay, so you're making a gamble here with the pension company. So if again we look at it as a series, so it's going to be 15,000 received straight away plus 15,000 received in a year's time plus 15,000 received in 2 years' time indefinitely. Okay, so what do I have to use here? Well, I've got an S infinity formula. Okay, I've got, like, if you ever see that word indefinitely in relation to series, your head should instantly go to that S infinity formula, that sum to infinity formula. When can I use that sum to infinity formula? Well, it's when my OR is less than 1. So what is my OR in this case? Well, just my A first is 15,000. And my OR is 1 over 1.03. So that is less than 1. So I can use the S infinity formula. So I'll just do it over here. So S infinity is equal to A over 1 minus OR. So that's 15,000 over 1 minus 0.03. So 15,000 divided by 1 minus 1. 15,000 divided by 1 minus 1 over 1.03. And that product would cost €515,000. Okay, so kind of more than the 20 because there's potentially more payments there. So €515,000. Okay, as I said, it's the part 1 and 2 I would focus in on that come up a fair bit on the exams. What tends to come up a good bit would be kind of putting the series of investments together with this. So, someone wants to get 15,000 a year for 20 years when they retire. How much will that product cost? €230,000. They are 40 years of age today, so how much do they need to save every month to get to this €230,000? So that's these annuities would come up quite often, and often paired with series of investment questions. And I will make a video kind of combining the two and put that up.